Hello, in this video we are going to talk about waves.
We're also going to talk about the characteristics of the wave and we're going to make an experiment of it.
We're going to explain the experiment and the mechanical waves in the experiment. Waves are means of transferring energy without matter. Wave is a disturbance going and travel through a medium. This means that the particles in the medium help the wave to propagate.
In the two types of waves, we can differentiate it in two different ways. The direction of vibration of the particles carrying through the wave and the medium through which the wave propagates. In the direction of vibration, the particles in medium can behave in two basic ways. Can vibrate in parallel direction to the motion of the wave and can vibrate in a perpendicular direction of it.
Based on the characteristics, we have two types of waves: electromagnetic waves and mechanical waves. All types of non-electromagnetic waves require particles interacting with each other in order to propagate. The substance that the wave is traveling through is called the medium. Mediums can be air, water, or strings. The interaction between the particles in mechanical waves occurs through contact forces. This means that particles are colliding against each other, and as they collide against each other, they cause their neighbors to move. This means that as they move, the wave is propagating to the medium.
Electromagnetic waves are the fastest waves that exist. So, electromagnetic waves don't need a medium to propagate. This means they can use electromagnetic fields and the vacuums. So, this means they don't need contact forces. Some examples of electromagnetic waves are light, radio waves, and microwaves. This means that when we use a microwave for cooked food.
The infrared, that is, refills the heat, and the ultraviolet light, that is the sun.
The X-rays and the gamma radiation. Given order is because the radio waves are the ones that have the lowest energy wave, and the gamma radiation are the highest one.
For the experiment part, we just built this wave machine to demonstrate how mechanical waves propagate.
This wave machine have a rover. The rover have to be attached to something rigid and has to be in tension.
So what we're going to show here is the movement of particles, and we are representing particles with the sticks. As the wave propagates by particles interacting with each other, this means that as particles vibrate, they cause nearby particles to do the same, and that's how the wave propagates. So we are going to do an example as that with only moving one particle, it is going to cause a chain reaction. Then, after the wave is over, particles are going back to their equilibrium position where they are totally still.
So we can clearly see how the Play-Doh moves up and down, but that isn't happening. The truth is that the disturbance caused that it feels like that we saw it like that. So we can change the amplitude of the machine by lifting more higher one of the sticks. So here we don't change the speed. What changes the speed is taking some Play-Doh on some region of the machine. So now
we're going to see that the part with the yellow Play-Doh will move a little bit slower than the section of the rubber that doesn't have the yellow bolts. Listo. Depending on the oscillation of particles, we classify mechanical waves in transverse and longitudinal. Transverse. Particles vibrate up and down while the energy moves left and right. It means disturbance. Longitudinal. The particles vibrate left and right at the same time energy, and one example is the sound. This means the propagation. This graph shows the movement of one particle in the medium. The horizontal axis shows the time and the vertical axis shows the displacement of the particle. The graph also shows 5 cycles. But what is a cycle? A cycle is what it takes to the particle to come back to its starting position. If we want to know how much time it takes for the particle to complete just one cycle, we have to calculate the period of motion. To calculate the period, we have to divide the time in the number of cycles. So, let's suppose the total time is 10 and we have 5 cycles. The division of this is going to give us 2. 2 seconds is the period. To calculate frequency, we only have to reverse the formula. Now, time is going to be down and the number of cycles is going to be up. So we have 5 cycles divided in 10 seconds. The result of that division is 0.5 Hz. Waves also have amplitude, which means how tall the wave is. The amplitude of the wave used in this chart is 2 millimeters, because we can see that from the rest position, the highest point in which the particle goes up is 2 millimeters, and the lowest point of the particle moves is minus 2 millimeters. This tells us which is the amplitude that the particle has in the medium or in the movement as it vibrates. Wavelength tells us how long the wave is. In this chart, we don't have time in the horizontal part, but now we have the position of the particle in the medium, and in the vertical part we still have the displacement of the particle. This example shows that the wavelength of the wave is 5 centimeters and that the amplitude is 2 millimeters. To represent wavelength, we use the Greek letter lambda. To calculate the speed of the wave, we have to divide distance in time.
For the wave, we're going to use as distance the lambda, or the wavelength, and the time we're going to use periods. So the speed of the wave, it's lambda divided in time.